Okay, so for 5.1 day 2, day 1 we learned if y equals natural log u, what's y prime? U prime over u, right? You take the derivative of the log argument, that goes in the numerator, the actual argument goes in the denominator. So now that we know how to derive natural log, we can do all those things we did last semester. So looking at number 1, relative extrema. What's a relative extrema? What's that mean? Maxes and mins. In particular, it's about a local max or min, not the absolute. What? Changing concavity is related to this. Usually I ask you about concavity in the same. You're thinking, though, I think points of inflection.
Yeah, you're right. Yeah, that's good. Sorry.
All right, so can anybody tell me what's happening at a local max or min? The sign of the first derivative changes. You're thinking of points of inflection, too, or it's easy to get them mixed up. Right, and so you could have a first derivative of 0. It could be like that, all right? But it has to be more than that. The signs have to change, but this is a good first step. Or, think about a cusp. What is the first derivative at a cusp? It's not 0, it's undefined, right? So what we're really going to look for is when is the first derivative 0? Whoops, I thought that was my 0, or undefined. Okay? And so we definitely need to find the first derivative. So this is a natural log of something, and even though this seems complicated, it's pretty easy to take the derivative of it just the way it is. So we're ready to go ahead and do that. And that would give us 2x plus 2. That's the derivative of the log argument. And then in the denominator would just go the argument. X squared plus 2x plus 3. So remember, we want to see where is this derivative 0, which part of the fraction is 0 when the whole thing is 0. The top or the bottom? The top. So if 2x plus 2 equals 0, then the whole thing is 0. When is this fraction undefined? When the bottom equals 0. And so I'm going to go ahead and write both of these and then solve so that I don't forget this one. Okay, so the left one's easier to solve. I'll do that one. X equals -1. So this is a possible min or max. It might not be either. It could be something else. And then you guys, I want you to solve this. If this factors, nice, but it actually doesn't factor. So if you have your calculator, solve it on your calculator. And if you don't, you get to do quadratic formula. In theory, a lot of this can be done without a calculator, but it gets kind of hairy from time to time, so a lot of this will actually be calculator stuff. Right.
Is it equals 0 times?
Did you get something weird? Oh, yeah, false. Who else got false? So that either tells us we did something wrong or it's just not possible. Who did quadratic formula? What did you get?
-0.
What did you get underneath the square root?
4 minus
So b squared minus 4ac. So 2 squared minus 4 times 1 times 3.
Oh, I'm sorry. I treated it.
Okay, here's the deal. That's okay. You should get a negative underneath the square root. And what type of numbers are these? They're imaginary, so you're right. There's no answer to that. There's no real answer, and we don't do imaginary numbers in calculus, which is nice. Okay, so right now we only have one possible number. So let's see, is it a min or max, or it could, again, like I said, it could be nothing. So we're going to go ahead and put this number on a number line, and there we go. And we are going to plug this back into y prime, and then that's going to tell us whether the graph of y is increasing or decreasing. So go ahead, think of a number that's less than -1, and remember we're plugging it into the derivative. not the original. We don't care about the y value. I want to know about the slope. So if you take a negative number, what's the result? Like if you take a number to the left of -1, the top will be negative, but what will the bottom be? Positive. So the whole result's negative, and that tells us then that the graph of y is decreasing. Is this coming back to you at all? All right, so let's keep going. Now we got to test a number over here. Probably the easiest number to test would be 0. But you can pick any other number that's greater than -1. And so what do you get as a result, positive or negative? Positive. So that means the graph then increases. So I have a decreasing, then 0, meaning the derivative is 0, then increasing. That gives me all the evidence I need to know that I have a min at -1. Now you don't need to tell me what the y value is here. The only time we really, from here on out, the only time we're really going to find the y values is when it's an absolute maximum. And I'm not going to really talk any more about that today, but we're just going to do relative today. So a min at x equals -1, and we always have to have our justification because y prime is changing from negative to positive. You could say y prime changes signs. It doesn't have to be negative to positive because the positive, well, actually, rewind that. You do need, to know a relative extrema, you just have to have changed signs. But in order for there to be a min, we do need this. What would be happening if y prime was changing positive to negative? Yeah, that would be a math, so we do need that. All right, so now let's kind of change gears a little bit, and let's do some implicit differentiation. You've had these on almost every single after party. The only thing that makes this different is there's a natural log in here. So you're going to have to take derivative of natural log. So remember, you're taking derivative with respect to x. So that means that every time you take a derivative of y, you got to have your dy over dx. So what should be the first thing I write here? Derivative of x squared. 2x. Pretty simple. Do I need to do product rule on the next part? No, because the 3 is just a number, so I just have to write -3, and then I can multiply that by the derivative of natural log of y, which is 1 over y dy over dx. This is where you need that dy over dx. Plus derivative of y squared, 2y dy over dx. And the derivative of 10 would be 0. Do you remember what to do next? Anything that doesn't have a dy over dx, we're going to subtract or add that over to the other side. And then we're going to factor out dy over dx. And I'm going to go ahead and write this as -3 over y. And then the divide step, very last thing. All right, now if this was a multiple choice problem, or let me do the other scenario. If this was a free response, meaning the problem looked just like this, then this is your answer. I suggest you don't simplify, because if you simplify incorrectly, you would be wrong. You'd lose your points. But if this was multiple choice, they probably wouldn't have this as an answer choice. What about this makes you think that it could be simplified? There's a fraction in the fraction. We call these complex fractions. Now, when what's giving you a complex fraction is just one tiny little thing, there's a really easy way to simplify it. We don't need to get a common denominator and do all that business. All you need to do is identify the piece that you kind of want to get rid of, all right, and we're just going to multiply that top to bottom. Again, I'm only showing you this because I want you to be prepared to correctly select the multiple choice answer if that was the case. So we'd have -2xy, and now when you distribute this y, that's going to cancel with the little y in the little denominator. to be just -3. And then what would the next term be? Plus 2y squared. If this was a multiple choice problem, this would be what your answer choices would look like. Okay, so you don't have to simplify, but sometimes you need to pick out the right answer. Okay? All right, so let's keep going. Here's another type of problem. Equation of the tangent line. What do you need to write the equation of the tangent line? You need the slope. You either need the y-intercept or you just need a point. And so this is how we typically see these. And I'm leaving blanks everywhere I'm going to have a number. Do I already know any of this? Or is there any piece of this I already know? Yeah, I know that x equals 1, so I'm going to put the 1 right there. I need to know the y value, and I need to know the slope. So, which do y'all want to do first? Doesn't really matter. So let's just do the y value first. So I want to know, okay, well, what does y equal? Well, it equals 3, and instead of x, we're going to plug in 1. And we're going to have to evaluate this. What's the natural log of 1? 0, right?
Oh.
So that totally goes away. That comes up a lot. So it's good to know. And then that whole thing simplifies to just 3. So that's the y value. I'm going to put that right after the y minus. Okay, now I need to know the slope. What do I need to do to find the slope? Derivative. So y prime is going to be 6x. I'm just taking the derivative of my equation. And now you can do the derivative of this natural log of x squared a couple of different ways. If we use the log property, what would that be? Yeah, I would move the 2 to the front, and then I would take the derivative of natural log of x, which would be 1 over x, right? Do you think I would get the same thing if I didn't use that log property? Or equivalent? Would it be equivalent? Yeah, because the derivative of x squared would be 2x, and the denominator then would just be x squared, and one of the x's would cancel. So it actually would work out either way. I really don't even think one way is necessarily easier than the other. So sometimes you're going to see that, like, I don't know if I should do this or that. Well, if you can do it, just do it however you want. All right, so we need to evaluate this derivative at the x value. So x is 1. I'm going to plug that in. And so I get 6. Oh, I didn't make that. This should just be a minus. 6 minus 2, that's 4. That's my slope. So all of this is just the same old stuff. Just somewhere in there you're going to have a natural log. All right, the last problem is a little bit harder. Okay? Whenever you get to these problems, from now on, when you see either points of inflection, concavity, relative extrema, any of these things, I want you to do one thing at the very beginning of the problem, and that is find the domain. And I want to make sure everybody understands what I mean. I mean, find the x values that you can plug into x. Graphing this is really difficult, so you're not thinking what are the x values on the graph. But sometimes you're like, well, I guess I can plug in anything. Well, you can square anything, but can you take natural log of anything? You can only take natural log of positive numbers. And so that's what I'm going to write here. You could write positive if you want. Whatever you need to do, because, and this is the same as the parent function. 9 times out of 10, it's just going to be this. Now, if this gets messy enough, your domain could change. And we'll kind of discuss that as it comes up. All right. The reason this is important is because if x can only be a positive number, then I know that I have no points of inflection at any negative numbers. That if any negative numbers come up, they can't be my answer. And in fact, 0 can't be an answer either. And this is going to help me with my chart as well, my number, my sign chart. So let's do relative extrema first, because that's the first derivative, and you got to find the first derivative before you find the second derivative. So go ahead and on your own, I want you to find the first derivative of this statement. You're going to have to use product rule for this. Oops. Okay, look at what I got. This is what you got? Any questions? Can we simplify this easily? I mean, if our answer was just find y prime, there'd be no reason to simplify. But I know that I'm going to have to, I'm looking ahead, I'm going to have to find the second derivative, and I know I'm going to have to do something with this. So if you can easily simplify something like x squared times 1 over x, then you should do it. It's only going to make your life easier. All right, so I need to know when is my first derivative undefined, and when is it equal to 0? Okay, so the undefined part, we actually already did that. All right, the derivative has the same domain as the original function, and that's going to happen a lot. But even if it's not, I still have to stay with positive numbers. If you just graph the derivative, everything is undefined for negative numbers. So we're going to, when we do the domain at the beginning, I don't really have to worry too much about the undefined part. All right, so I can factor. What can I factor out? I can factor out an x, and I'm left with 2 natural log x plus 1. And so I get x equals 0. Can x really be 0? No. This is just popping up again because of the whole undefined thing. So again, I just want you to, this is why we figure out the domain at the beginning. All right, then I have 2 natural log x plus 1 equals 0. In order to solve this equation, we've got to isolate the natural log of x. Okay, so I would subtract 1, and I would divide by 2. We know we can't take natural log of a negative number, but can natural log equal a negative number? This has to do with range. Can negative numbers be part of the range? Yeah. Really, natural log can equal any number. And so, anybody tell me how we're going to solve for x? Or what do you think x is? This has to do with the exponent log redo. So e, since it's the base of the log, e to the negative 1/2 equals x. Just rewrite it from log to exponent. That's what we're doing. That makes sense? So this seems wrong, but this is going to happen a lot on these problems. Now, it's hard to kind of visualize what e to the negative 1/2 is, so I want you to go ahead and type this in your calculator. Make sure you can find the e button and do diamond enter so that you can have a decimal. And that way you'll kind of know where this number is on the number line. And you should always get a positive number, because e to any power, always positive. We're just doing E every time the E button. It's by the home button, I think. It's blue. or I guess that depends on your calculator. Could be yellow. So 0.607. All right. So we're going to go ahead and make our chart. I am going to go ahead and put 0 on my chart. All right, but I'm also going to totally scratch out everything to the left. Remember, nothing is even happening to the left at 0. Nothing's really even happening at 0, but definitely nothing's happening to the left. So I don't have to test any of those numbers or anything. All right, and then E, this is a positive number, which I told you it has to be, and that should make sense because otherwise it would be off the chart. It was just like what we did on number 1. So we got to pick a number between 0 and 0.6 to plug in. So 1/2. Now you could do this by hand and in your head, but I'm going to say you're going to get to use your calculator on this. Let me tell you how you would do this. If you pick a really, really, really small number and you plug it in, and I'm going to plug it into this one right here, natural log of a tiny, tiny, tiny number is actually a really big negative number. And this makes sense if you kind of look at the graph. So the smaller the number you plug in for x, the larger and negative the natural log is. So what do you think the result's going to be? Negative, all right? But you can definitely use your calculator and do like 2 times 0.1, natural log of 0.1 plus 0.1. You're going to get a negative result, which means that my y value is decreasing in this tiny, tiny little interval. It'd be hard to even see this on the graph. All right? It'd be a lot easier to plug in a number outside here, so like 1. I picked 1 because I would go 2 times 1, that's 2. But natural log of 1, that's 0, plus 1, that's positive. Any questions about how I'm getting this, setting up this sign chart? Because we've done this a lot, but I know that there's a lot of little things that can go wrong on this. Kind of confusing. So, back to what we were even finding, relative extrema. I see a min. This looks a lot like 1. So I'm going to say I'm going to have a min. It's happening at x equals e to the negative 1/2. You could put the decimal here if you wanted, as long as it's accurate to 3 decimal places. You still need your justification. It's because y prime is changing negative to positive. And that's your only extrema. If you're not careful, you might think there's an extrema happening at 0. But there's nothing happening at 0. In fact, that's an asymptote on the graph. All right, so that's half the problem. But I will tell you that the second half looks exactly like this, except with the second derivative. All right, so second derivative. Definitely go from the more simplified first derivative. It's going to make your life easier. Okay, so let's do this one together. I see y'all are getting a little tired. I understand. I'm tired too. So derivative of 2x, that would be 2, and then we just write natural log of x. Okay, plus, now I get to just write 2x and take derivative of natural log of x, and then derivative of plus x, which would be plus 1. And if you can simplify this, you definitely want to. It's going to make your life easier if you simplify. Just be really careful and make sure that you're doing that correctly. So what is 2x times 1 over x? Yeah, just 2, right? And then the 2 plus 1, that makes 3. Is this undefined at all? Yeah, it's the same thing. Look, it's the same domain. X has to be positive if you're going to take natural log of it. All right, so let's just go ahead and set this equal to 0, and it's going to look very similar to the next problem. In fact, I want you to go ahead and see how far you can get in this problem. Keep in mind, this is point of inflection. This has to do with concavity, but the essential steps are essentially the same. All right, so just to finish this one out, you should have gotten natural log of x equals negative 3/2. So then what would x be? E to the negative 3/2. What is that as a decimal? It's 0.2 something. Okay? Alright, so you gotta do the sign chart. You gotta put 0 and you gotta scratch everything to the left of 0 out. It can be confusing otherwise. And it may not seem that way on this problem, but when you get there, especially if your domain changes, you want to cross off what you know can't be the answer. Alright, here's e to the negative 3/2. What were the signs that you got here when you started to plug it into the second derivative? So let me explain to you one more time just how you can get this add calculator easily. If you decide to plug in a really small number in for x, natural log of that is going to be a really big negative number. Okay? So that means negative, in this case, concave down. If you drew an arrow going down, that's not correct. It's concave down because second derivative has to do with concavity. And then over here, positive, concave up. What if both of these were negative? What would that tell us about our point of inflection? There wouldn't be one, right? Same thing if they were both concave up, or I don't know if that's what I said. They're the same. There's no points of inflection. Here, though, we do have a point of inflection. It's happening at x equals e to the negative 3/2. Again, I'm really not going to ask for the y value here. If I do want the y value, I'm going to be very specific about putting that in the instructions. You would, though, just go back up to the very original thing, you plug e in, and all that, okay? Right now, I'm more concerned about the where part. So, point of inflection, because, what's our justification? Yeah, I need to use calculus, though. So I need to use this derivative, second derivative, goes from negative to positive.
Yeah.
The fact that the graph is changing concavity is great. It means you understand what you're doing, but they're really, the AP graders are really looking for a very specific thing here. Alright.